So we went over Thursday, we went over a lot of material about probability distributions. And basically, what will I test you on in probability distributions? 6.1, I will test you on finding the mean and the standard deviation. Now, I believe, if I'm not mistaken, we started on the mean. I believe that's what the last thing. Somebody help me out. I think we started on the mean. And the mean of a probability distribution is equal to the summation of the event times the probability of the event. Now, I need somebody to look back in their notes and make sure that we did cover that. I believe we did.
Yes.
Thank you. Okay, so what about the standard deviation? Well, I can't remember if we got that far, but the standard deviation of a probability distribution is going to be equal to the summation of x squared times p of x minus the mean squared. And I believe, yeah, I believe that's, better put this in brackets. There we go. Now there's two formulas in the book, but I use this one. Okay. And I don't know why my hand just froze, but it did. Hopefully somebody said something. Hold on just a minute. Probably somebody fussing me out for not showing up today at class. Oh. Okay, can everybody hear me okay?
I can.
Okay, I need a couple more people to say if they can hear me or not. If you can't hear me.
Yeah.
Okay. Okay. Miss White, is there nothing coming in or is it broken up? She didn't say. Okay. Well, she can't hear me. Miss White, let me kick you out and bring you back in. Sometimes that will work. If not, you may need to reboot computer. Okay, I'm going to kick you out. Sorry about this. So let me kick her out. I got to go to enrollment. Miss White. Remove. Okay, she's gone. And let me bring her back in. Sorry about that. Miss White, can you hear me now? Sound like a TV commercial. Can you hear me now?
Hello?
Miss White, can you hear me now?
Yeah, it's on my phone, but I don't know
I'm
what
sorry,
happened.
say again.
Can you hear me?
Yes, I can hear you.
Yeah, the call is on my phone. It's not on the computer. I don't know what happened.
So when you're on your computer, you can't hear me?
Yeah, I tried to turn up the speaker and everything, but I don't know what's going on.
Maybe you need to restart the computer. You might need to try that. Let me bring you back in if you want me to try, or you just, you can just do it from the computer. I mean, from your phone, either one.
Okay, I'll just try that.
Okay. And Miss Dennis, are you in here? Miss Dennis, are you in here?
I'm in here and you are not, sir.
I know. Don't. She. I told you she was going to make me feel bad. I had a bad night, Miss Dennis. I didn't go to sleep till 3 o'clock. I couldn't sleep, and I just woke up at about 5 or 6 after 8. So
That was when I called you, right?
well, I must have been in the shower. I must have been in the shower because I saw somebody called, and I don't think I've ever had anybody call me from Massachusetts. So that's real.
Me. Yep. I said he didn't answer because he saw that number.
Yep. So thank you so much for calling me, and I apologize. I really have not made a habit out of this. I've not. I can't even remember the last time I was overslept, but I'm sorry.
Things happen.
Well, I appreciate it. Okay. So thank you for. I told you she'd make me feel bad. I knew she was at the room. I knew it. Okay.
I'm thinking of your
So
right now.
okay, I brought you in because Miss White could not hear us, and I saw that you were online, so that's why I called you in. So I'm glad you're here, and I'm glad Miss White. Miss White, do you want to reboot your computer and let me try it, or do you want to stay on the phone?
Yeah, I could shut down the computer, try it.
Okay, shut down the computer, stay on the phone, and let me know when the computer reboots.
My left hand.
And I will kick you out and bring you back in, okay?
Okay, do you want me to hang up from the phone?
No, after the computer boots up, just let me know. Just type it in the chat and let me know that you're going to hang up, and then I'll bring you back in, okay?
Okay.
After you get your computer ready, just type in the chat. I'm going to leave the room, and I will bring you back in. And please tell anybody at the room. Are you still at the room, Miss Dennis?
I'm sorry. What did you say?
I said, are you still at the room?
Oh, yeah. I'm not leaving.
Okay. Is anybody else there?
Yes, there's 4 of us here.
I'm sorry. Say again.
There's 4 of us here.
Okay. Well, I apologize to all 4 of you. I didn't even have a chance to call the front desk and tell them, so I'm so sorry.
Nobody was even there.
I'm sorry. Say again.
Nobody was even at the front desk this morning.
Okay. Well, Elaine, I guess I'm not the only one that kind of overslept. Okay. So we went over the mean of a probability distribution. We went over that Thursday, and that is x times p of x. And then today, I just wrote down the standard deviation of a probability distribution. So if this, oh, I'm sorry, that's the variance. So what is the relationship between the variance and the standard deviation? Standard deviation is always the what? Come on, I taught this to you in chapter 3.
You don't want to look on the computer?
Okay, Miss Miss White is ready, she said. So I'm going to kick her out again. Let me kick Miss White out of the class. Oh, Lord, I guess we could write this down as a crappy day. What do y'all think? Remove from
Yeah, it's
meeting.
not going well.
Oh, gosh. Okay, Miss White, I kicked her out, and I'm going to bring her back in. So give her a second to make sure. Okay, Miss White, and bring her back in. And if there's anybody in the room with Miss Dennis that wants to come in or already in, I appreciate it. I'll make this up to y'all. I'll make sure I bring donuts or something next Tuesday. I'm sorry. Okay, now everybody's going to show up if I bring donuts. What is the relationship in chapter 3 between the standard deviation and the variance? Can
Is
anybody
it
remember? Go ahead.
standard deviation like the square root of the variance?
That's right. So I'll put a square root, and I'll just put variance right there, which is this right here. Okay? So if I take the square root of this function right here, that's going to be the standard deviation. Now I'm going to do an example, of course. I can't remember if we did the example of the mean last Thursday. Can somebody look in their notes and tell me?
I think we did.
Okay. Well, then what I will do is I will pull up the handy dandy slide. Well, I'll pull up a homework question. How about that? Let's just do that. And let's just do a homework question. At least I know that y'all will do at least one homework question because I'm going to do it. All right. So, of course, let's see. Assignment. And this is going to be 6.1. And let's see if I just going to find a probability distribution, and we're going to do both. Okay. This is a probability distribution. Let's check and see if it's, I'm just going to do both. I don't know what the question is going to ask. Got 7 parts. Good gracious. But we're going to go ahead and do, I opened it in Excel. Why didn't it come up? Let me do it again. Oh, there it is. Okay. So here is probability distribution. And go ahead and write it down. I'll make it a little bit bigger for y'all. And I'm going to write the handy dandy. Okay, somebody done tapped. Let's see. Oh, I'm sorry, Miss Nagayan. I will have to restart my computer. It's still lacking. Be right back. Okay, well, go ahead and hopefully you can come back in. You want me to remove you and bring you back in?
I'm good now. It's okay.
Oh, thank you. Miss Nagayan, you came back in by yourself?
Yes, sir.
Wow, I didn't know you could do that. Okay, that's great. Okay, so here is the, no, I don't want to update. Just give me the dadgum. I'm going to draw the, I'm going to try to. So my mean, I'm just going to put mu is equal to x times p of x, and I'm going to add that up. Okay, And then my variance is going to be equal to the summation, of x squared times p of x, let me redraw that, times p of x and subtract mu squared. And then the standard deviation, I'm just going to call that sigma, or S, is equal to the square root of the variance. Okay, so there's the three formulas we're going to be using. Now, let's check. We got to do our test to make sure that this is a probability distribution. And somebody remind me what the test is. What do you do to check to see if this is a probability distribution? Come on, everybody, don't speak at once. There's two tests. I went over this Thursday. Look in your notes. It's probably the first couple of things I said. There's a test, two tests that you check to see if this is a probability distribution.
You add the numbers up so that
I add the numbers up, the probabilities, I add them up. So let's do that. Bingo. And it's supposed to equal what? 1.
One.
Good. All right, that's one test. So what's the other test?
Check if there's a negative.
Each of these has to be between 0 and 1. That means there cannot be a negative and there cannot be anything greater than 1. So 26 cent, 58 cent, 13 cent, 2 cent, 0 cent, and 0 cent. So everything's good. There's no negatives and there's nothing above $1. So this is a probability distribution. So I'm going to mark it green so you know that it's a probability distribution. So we did our test. I'm doing what I'm going to test you on right now. These three things over here. And is this a probability? That's what I'm going to test you on in 6.1. So if you can do this problem that I'm doing right now, what I'm doing, then you can pass the test for 4.1 because this is what I'm going to test you on. All right, so x times p of x. So I'm going to color this. I'm going to use a highlighter and I'm going to color this magenta. And that's going to go away. So I'm going to do the x times p of x. I'm going to do that in magenta. Oh, the things I do for y'all. So over here, I'm going to spread this out a little bit. And I'm going to say x times p of x. So that means I'm going to take this number and multiply it by this number. And I'm going to copy that down. And then I'm going to copy this, or I'm just going to. And that, folks, is the mean. So I'm going to color all of this magenta. And this magenta. All right, now's the time for those of you that have questions. Ask them.
Excuse me.
Yes,
So to complete this problem, you have to do all three of these steps?
yes, these three over here.
And
But
once you do all three of them, your
First, you
problem is
gotta,
complete.
first you got to test it, okay?
Yep.
And I did the test. You gotta add up all of these numbers,
Mm-hmm.
and they should equal 1. And then each one should be between 0 and 1.
Mm-hmm.
That's the first thing you do. The second thing you do is you do these formulas. And that will be pretty much what I ask you of you. I don't know why that won't. That is driving me crazy. The top will not do just like these did. Oh, anyway, that's what we're going to be doing. Now, what the question asks, I have no idea. But we're going to see what the question asks after we do everything that I want to do. Okay, so we just did this right here. So now we got to do this. So you got to read the formula. Read the formula, and it says the summation of x squared times p of x minus the mean squared. Somebody tell me what is the only thing we don't have in this formula? We got the mean. There's the mean right there. That's mean. We got p of x right here. So what's the only thing we don't have?
The variation.
Yeah, that's what we're trying to find. But in the variation formula, in this formula right there, there's three things.
That sum in x squared?
X squared. We don't have x squared. So I've got to make a new column, and I'm going to highlight it orange. We've got to get this before we can do anything with this formula. So I'm going to go over here, and I'm going to find x squared, which you really don't have to do an Excel spreadsheet. Everybody can find x squared. You just do it in your head. Okay, what's 0 squared? 0. What's 1 squared? 1. And so on. So I'm going to copy that down. So that wasn't hard. So now we've got to do x squared times p of x. So I'm going to go over here, and I'm going to
I
make
have a question.
Yes, yes, yes.
So for the x squared, you're not doing the decimals, like the 0.582 squared?
No, that's p of x. See, that's p of x. P of x is right there. We're going to use p of x, but we're not using it right now. We got to get x squared first. See,
Okay.
the formula says that you've got to take x squared and you've got to multiply it by p of x, and then you got to add that up. Okay, so right now we don't have x squared. There's no x squared here. Okay, every once in a while, my internet just drops for a split second. So I hope y'all are still there. I don't know why it does it, but it does. Okay, so I apologize. Okay, so to answer your question, Miss White, we've got to get x squared, and I just did that right here, so I'm going to highlight that orange.
If
Okay.
we just got x squared, shouldn't the values be squared?
I thought I did square. Oh, I'm sorry. Thank you. Oh, my Lord. I didn't square them. Maybe that's why Miss White was asking the question. There. Now it should square them. Oh, my Lord. I need Mountain Dew or coffee or something. All right. I need my drink. I can't tell you what's in that drink, but I need it. All right. So anyway, there we go. Actually, that drink is a lot of fruit juice and celery and vegetable juice. So anyway, there's x squared. There's that right there. So now we have everything we need to do the variance. We need x squared. We need p of x, which we got p of x right there. That's, so I'm going to take my green highlighter. Where's green? There's green. And go away. We got p of x right there. P of x is right here. And we're going to subtract mu squared. And I've got mu, I'm sorry, right here in magenta. So I'm going to color that magenta right there. Okay, so we got to do x squared times p of x. So I'm going to spread this out a little bit right here. And I'm going to do x squared times p of x. So somebody tell me what the first one would be. Well, that would be 0 times what? Times 0.261. And you could actually do the first one in your head. 1 times 1, which is 1. So let's see. I'm going to highlight that. I'm going to use my red pen. And I'm going to highlight that in red. What do we do with x squared times p of x? After we multiply it, what do we do?
Subtract the mean squared.
Not subtract, but what's the funky E? What does that mean?
Oh, find the summation.
We got to add them all up. So I'm going to take my handy dandy highlighter and I'm going to highlight this. And I don't know if I can or not. No, I can't. I was gonna do it in. I guess I can't. I was gonna do it in red. Oh, there it is. I did do it in red. Now I just gotta make it bigger. Well, there it is right there. All right, so we're gonna do a summation right here, and that summation is gonna equal all of those numbers. Oops, it's supposed to be this one. I apologize. I messed up.
I have another question.
Yes.
How'd you get the numbers in the last column?
How did
Is
I
that
get
x
these?
squared?
What does that say up here? X squared what? It's supposed to be squared, sorry. X squared times what?
P of x.
So I took x squared column and multiplied it by P of x.
Oh, okay.
Got it?
Yes, thank you.
Okay, and I'm going to do, there we go. And that's going to be this right here. So I'm going to summation. Okay, so my red right here is 1.399. So that goes right here. So I need y'all to take a piece of paper and write 1.39 variance is equal to 1.399 minus 0.931 in parentheses squared. Because that's what we're fixing to do right now. So my mean is equal to that number right there. And we colored that magenta. Okay, and my variance is going to be equal to, I'm going to take 1.399 and I'm going to subtract that mean, and then I'm going to square it. Mean squared. And there is my variance. And then the standard deviation is equal to the variance raised to the 0.5 power. And we've been doing that since chapter 3. So y'all should know that. Or the square root of the variance. And that is how you do, and we're going to do another one. We're going to do 2 or 3 of these. That's how you do 6.1. That's by the time you get to the end of 6.1, that's what you should be able to do. Find the mean, the variance, and the standard deviation of that right there. Okay, so I'm waiting to see if anybody's got a lingering question or a question that, you know, they don't understand. I tried to color coordinate with the formula, so I know it's kind of jumping all around, but that's why I did. So if you want to color, if you want to use a color for the variance, we'll use blue. So the color of the variance, that's this right here. Actually, that's not a good, yeah, there we go. And then the standard deviation, we'll color it, I don't know, some yellow. And that is right here. The 3 things right there that you need to be able to do for 6.1. Now, they may ask you to draw a graph of this. I told you that a graph really didn't matter, but sometimes in the homework or the test, they ask you for a graph. And let's see. There you go. Somebody tell me what kind of graph this is. That means I want y'all to say something, you know. Y'all should know how to draw. Y'all should know how to draw. Y'all should know what that is. Because the middle is about right in here. So somebody tell me what kind of graph this is.
A bell curve?
Bell curve's in the middle. But that's a good guess. You got 3 choices. It's not a bell curve because that would be, the hump would be in the middle. What's the 2 other choices? Starts with a S.
Like skewed right?
Skewed what?
Is it right?
It's skewed right because the data is on the left-hand side. So this is skewed, sorry. this one is skewed, or the data is skewed right, because all the data is where? On the left. So the data, when you draw a picture of the data, it's a little bit skewed left. I mean, skewed right, because the data is on the left side of center. And center, how many dots you got here? 1, 2, 3, 4, 5, 6. What's half of 6? 3. So 3 is around the middle. Okay, you can just draw between the dots. You know, I'm between the third and fourth dot. I might need to move it to the left just a hair, but that ain't big deal. Okay, so this is all I'm going to ask. I don't know of anything else. Okay, there's one more thing I could ask, or not me, but the homework question. What is the probability? Does anybody remember what the question said these were? What events these were? Let me look right quick and see what the events are called. In the probability distribution to right, number of marriages. Oh my Lord. Number of marriages what? An individual age 15 years or older have been involved in. Oh my Lord. Might as well say funerals. Anyway, how many marriages? So let's go back to the spreadsheet. So 1 marriage, 0 marriages, 1 marriage, 2 marriages, 3 marriages, 4 marriages, and 5 marriages. Okay? So somebody tell me, what is the probability of having 1 marriage in a lifetime? Okay, everybody should jump on that. 1 marriage. What is the probability of having 1 marriage in a lifetime?
.582.
Good job. 0.582. These are the simple questions that they might ask on a test or homework. Somebody tell me what the probability of having 5 marriages.
.001.
0.001. I do actually know of people that have had 0 marriages, 1 marriage, 2 marriages, 3 marriages. I know somebody that's had 3 marriages and somebody that's had 5. I don't know anybody that's had 4. Well, this person, but whew, I've only had 1 marriage. I want a second one. Oh my goodness. So anyway, all right. Now I'm going to ask you a question here, and remember, are less than or greater than or less than or equal to. You remember those inequalities? I want somebody to tell me the probability of at most 2 marriages. Somebody tell me what at most 2 means.
You can have 0, 1, or 2 marriages.
Exactly. You're going to add up those 3. So you need to write that down. At most 2, you're going to add up 0 probability, 1 probability, and 2 probability. So that's going to be 26, that's 70, that's 80.803, and 0.931. I don't know. Add them up and see what you get. I got 0.931, but I may be off. I'll do it in my head.
I have .971.
971. Okay, so what is the probability based on this of people having at most 2 marriages? Well, that would be 0.971. There's a 97% chance based on this data that most people have had at least 2 marriages. What's the average marriage? Somebody tell me what the average marriage is. It's in green right here. I'm pointing at it right here. It's right there. I'm circling it. I want somebody to say it.
1.
1. Thank you, Miss White. I appreciate you and Miss Cameron's cooperation. Rest of y'all waiting on a pickle. Miss Dennis, you should be helping me out here. Okay. The average is 1. That's what mean is. Mean is average.
If I helped you, my answer would always be 0. Don't get married.
Yeah. Are you with me that 0 marriages is good?
Yep, 0 equals 0.
Yeah. If I could give out any advice to anybody, I would say, well, I tell all my advisees, I say, take every psychology course offered at your college. Why? Why do I say that? Because you're going to be working with people in the work world and you're going to be in a relationship. And the more psychology you have, the better, because people are crazy. And you got to realize who is crazy and who is not. And the more psychology you take, the more you're going to be able to find the guys that wear sunglasses inside, they're crazy. And the girls that wear too much makeup, they're crazy. And you got to be able to pick these things out so you can stay away from those people. Right, Miss Dennis?
No, because the guy that seems too good to be true is crazy.
The guy that seems too good to be true is usually the one that has the most skeletons in the closet.
Yes.
Yeah, that's true. That's the same thing as I was saying. The guy that has the sunglasses inside, you know, and has the smokestacks on the truck, on the pickup truck, that's the same as the girl that wears too much makeup, has an orange face and a white neck. They're both crazy and they got skeletons in the closet. Run the other direction. The other advice I always give you, besides take all the psychology classes you can, is wait until if you're a female, wait until you're 25 or 30 before you get married. If you're a male, you should not get married until you're 40. Am I right? Am I not right, Miss Dennis? Men should not get married until they're 40. It should be in the Constitution, amendment to the Constitution, because they're not mature enough to handle a marriage or commitment until they're 40 or 35. And I'm talking about 80% of the male population. There's some good ones out there that can get by with 20%, but not many. I think I did good to do what I did. So anyway, all right. So that's it. Let me ask you one more question. What is the probability of at least 4 marriages? What does at least mean? That means that your lowest number is what? 4. At least 4. So somebody tell me what at least 4 marriages. What is the probability based on this research that you would have at least 4 marriages?
0.005.
0.005. You would add those 2 up. 0.004 and 0.005. I'm at 0.004 and 0.001. Now, a while ago, I was pointing at the wrong place. I was pointing at this for 1. This is 0.93, and I told you that we do not have decimals in households or people or marriages. So you don't have 0.93 marriages. That's 1. You round that up to 1. So the average, I was pointing at the wrong place. The average is 0.931, which would be rounded up to 1 because you don't say 0.93 marriages. You say 1 marriage. So the mean is 0.93, which is 1. I was pointing at the wrong place. I'm sorry. Okay. So I think I've done just about all I can do with this problem. So I hope you got all this written down because we need to go over to the question and see what it asks. Okay, so I'm gonna write this down because if I ask y'all, y'all not gonna tell me. So I'll just write down the mean is equal to 0.931 and the variance is equal to 0.532 and the standard deviation is equal to 0.73 and it is skewed right. We said that, and I'll just go back and see what it asks for now. And where's my question? There it is. And I'm going to delete all this. Yes, continue. All right, this is a discrete probability distribution because all of the probabilities are between 0 and 1. And the sum of all the probabilities is 1. Good job. And what does our probability look like? What does our graph look like? Somebody tell me. Alpha, Bravo,
C.
Charlie, or Delta?
C.
C.
Charlie, as in Charlie Bucket. Any Willy Wonka fans out there? I love Willy Wonka. Next, the distribution is it's not uniform. Has one mode. Let's see. I don't think we have one mode. It's not bimodal, and it's not multimodal, so it'd be uniform. It'd have to be uniform because you don't have any modes. You don't have anything showing up. I don't.
When I did that question,
right. Say again.
I put uniform, but it said it was wrong.
Okay, then let's go with multimodal.
I put it has one mode.
Coming in on secured channel.
I'm sorry. What'd you say? My phone rudely interrupted you.
It's I put it has one mode.
And that's what it wanted?
Yeah, it was right for me. But I put
Yeah,
uniform
okay.
the first
Now
time.
I don't really understand the one mode because a mode shows up more than once or the most. And the only thing I could come up with was since the standard deviation is 1, since the mean is 1, maybe that's why I say it. I don't understand why. I guess I know why. Because the highest number is 0.582. So if the highest number was 0.582 on 2, it would be bimodal. If it was 0.582 on any of the 3, 4, or 5, it would be multimodal. Does everybody understand that? If 0.582, the highest number, was on 0, it would have no mode. If 0.582 is on 1, it's going to be one mode. If the highest number is on 2, it's going to be bimodal. And if the highest number is either at 3, 4, or 5, it will be multimodal. Does everybody understand that now?
Okay, so it's not based off of like what number appears the most, it's based off of the highest probability.
Well, yes, because the highest probability represents the number. So if the probability is the highest at this number, then that shows up the most. Think about it. If this probability is high, then this number shows up the most. You see what I'm saying?
That makes sense. Yeah, that makes sense.
Yeah, you got to look at it that way. I don't care nothing about the mode anyway, but I do care about the skewed right. Next. There's our mean. It says type in as a decimal. It does not say round. So 0.931. We got a nice work. Which of the following interpretations of the mean is correct? The observed number of marriages will be less than the mean number of marriages for most individuals. If any number of individuals age 15 or older were surveyed, one would expect the mean number of marriages to be the mean random variable. That might be true. If any individuals, blah, 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 one would expect the mean number of marriages to be the mean of, that says the same thing. Hold on. If any number, I would say any number. I wouldn't say many individuals. That doesn't sound right. In probability, you don't say if many individuals aged. I would say if any individual. I like B so far. The observed number of marriages be equal to the mean number of marriages. No, that's not necessarily true. I would say B. Nope. Then C. I don't agree with that. I don't like using the word many. If many individuals were surveyed, I don't, as a math teacher, I don't like that word many. I would rather use the word any, but they, so if, yeah, just remember that word right there. Okay, what's our standard deviation? Our standard deviation says round to 1 decimal place. So that would be 0.7. What is the probability that a randomly selected blah, blah, blah was involved in 2 marriages? Not up to 2 marriages, but 2 marriages. 0.128. Okay. What is the probability, blah, blah, blah? There we go. At least 2 marriages. At least means that the lowest number is what? 2. So somebody add those up for me. Let's see. 1.14, 0.152, 0.156, 0.157. Do y'all get 0.157?
Yes.
All right. So here we go. Y'all ready? Oh, I don't want that question. I want another question like we just did. All right, this one's good enough. I hope, let's see. Let me put it in a Excel spreadsheet so you can see it better. I want y'all to do everything we just did with these. Let me make sure it's a probability distribution first, because I don't want you to, I'm going to check that for you, and I'm going to change it if it's not. So let's check to see if it's a probability. It is. All right, now I want y'all to do everything I just did with the previous question. I want you to do it with this one. I'm going to give you 5 minutes, maybe 6 minutes. I'm going to put you on the stopwatch. Or let me put it to you this way. Do what you can. How about that? Do what you can. And I'm going to start you off right now. I'm going to show y'all, keep up with y'all's time. There we go. And there's your formulas. Okay. Okay, that's 5 minutes. And you should be able to at least get a few things done. right quick, before we get started on the actual formulas, somebody tell me the probability of one marriage. Or whatever this, we're going to say one event. What's one event? What's the probability of one event?
0.42.
0.42. What's the probability of at least 3 marriages? At least 3 marriages.
0.24.
Yep, 0.24. You would add those two together. Okay, at least means the lowest number is 3. Okay, now we went over that Thursday. I went over the at least, at most, greater than, less than. Speaking of greater than and less than, how many would be, what's the probability of less than 2 marriages? Less than 2 marriages. 0.68, right? Now, why didn't I include 2? Because less than 2 marriages does not include 2. Now, if I said at most 2 marriages, at most 2 marriages would include 2. So less than 2 marriages would be 0.68. At most 2 marriages would be 0.76. Let's graph it. Graphing's real easy. Just hit insert and okay. All right here, so it's a little bit skewed left. Now, what kind of mode we got? Well, where is your biggest number? 0.42, so this is single mode. Okay, so that's some of the things we can do without formulas. What is the probability of 4 events? 0.17. Okay, so those are the things we can do without formulas. Okay, with the formulas, first of all, I'm going to find the mean. I'm going to multiply x times p of x. So I'm going to have this little area right here. And I'm going to say x times p of x. So that's going to equal this times this. And copy that down and summation. So our mean is equal to 1.47. We're going to put that in green because that's our mean. Mean is equal to 1.47. And all I did was read my formula. Summation of x times p of x. X times p of x. I did each one of them and added them up. Now for my variance. My variance, we're going to have to actually do x squared because the formula says x squared times p of x. And I got to sum that up. X squared times p of x. So I've got to get another column over here and call it x squared. And that's going to equal this number raised to the second power. And I'm going to show you how to do it this time after we finish this, I'm going to show you how to do it on a calculator. And I'm skipping a column so y'all can see that I'm going to do x squared times p of x. X squared times p of x. Times p of x. So x squared is equal to this guy times p of x is equal to this guy. And add that up. And that's equal to 4.09. So if I got my formula out, this area right here is equal to 4.09. Right here. So I'm going to write, I'm going to put a circle around this. And that's equal to 4.09. And now I'm going to subtract 1.47 squared. All you got to do is read the formulas. Just read them. Okay, so down here I'm going to go variance is equal to, I'll take my 4.09 and subtract parentheses 1.47 raised to the second power, close parentheses. Okay, that right there, I want everybody to look at 8.7 right here. I want you to look at that. And then look at your formula right here. H7 is 4.09 minus the average squared minus D7 squared. So 4.09 minus 1.47 squared. That's what I just typed in. And I'm just going to hit enter. And there, and of course the standard deviation is equal to the square root of the variance. So that's going to be 1.93 raised to the 0.5 power. And there is your answers. Now I'm going to show you how to do it on a calculator. So I'll come back to this. Let me get the calculator pulled up. Handy dandy calculator. Handy dandy spreadsheet. All right, y'all ready? Get your calculators ready. Here we go. First thing I'm going to do is clear. And y is equal. I'm going to clear everything there in case I want to delete. Okay. Okay, so here we go. I'm going to hit Stat, Edit, and I'm going to type in my 0, 1, 2, 3, and 4. Now I'm going to type in 0.26, 0.42, 0.08, 0.07, and 0.17. All right, I'm giving everybody another extra few seconds to type those in your calculator. I had to make up my drink concoction while y'all were doing that problem. I have to have something to drink. Okay. So now what? Well, now you hit stat, calculate, and hit first variable statistic. All you got to hit is return. And on frequency list, I want you to hit second 2. You'll put in L2. And if you look above the 2, you'll see a L2 there. That's what I just hit. Second 2, which is L2. And calculate. And there's your 1.47. There's your mean. And your standard deviation is sigma 1.39. Don't you feel good about yourself? Let's graph those points and see what they look like. These points right here. So I'm going to hit stat, second, y is equal. Hit enter to turn the plot on. And I'm going to make mine look like a line graph right here. See that, the second one right there? I'm going to hit enter, and now I'm going to draw it. So, graph. Now you can't see it, so you're going to hit zoom, and stat should be 9. There you go. Now, I don't mean to sound insensitive, but you should find which way you're good at. Okay. Now, if you like doing this by hand and just using a calculator to assist and doing it by hand in columns, that's fine. That's 3 ways that you can do these problems. Okay. Calculator, Excel spreadsheet, or by hand. But you need to be able to do it. Okay. Because that's what I'm going to test you on in 6.1. You need to be able to find the mean, the variance, and the standard deviation. You need to be able to graph it, graph those numbers right there, just like I did. And you need to be able to answer questions like at most 2. At most 2 means 2 or below, so that would be these 3 numbers. Okay. What is the probability of 4? That'd be 0.17. What is the probability of at least 2? At least 2 would be those 3 numbers. Okay. So that'd be 0.08, 0.07 is 0.15, 8 cent and 7 cent is 15 cent. And 15 cent plus 17 cent is 33 cent or 32 cent, something like that. So it'd be 0.32. Add those 3 numbers up. At least 2 means the lowest number is 2. At most 2 means the highest number is 2. Less than 3, that would be these 3 numbers. More than 2 would be those 2 numbers. You got to know the difference between your inequalities. Okay, that's why I spent the whole period Tuesday showing you these and showing you that this means less than, this means greater than, this means at most, and this means at least. Or let's see, this means at least. And this means at most. And we went over that with the number lines. This is what we went over Tuesday. Whatever last Tuesday was. Okay. So Now, when you look at these and I say at most 2, well, at most 2 means that the biggest number is 2. So that means 2 and below. So that would be 0.08, 0.42, and 0.26. Okay, now we're done and we went over, so we need to shut her down. And what I would do if I was you tonight for homework on 6.1 is pick out a couple of questions like we just did today and make sure you can do them. Make sure you can do everything. Now let's go answer the question. I don't have, let's see, 1.47, 1.47, 1.93, and 1.39. I'm going to go through the question and then we'll shut her down. If you have to go, just write a note on the thing, on the messenger saying you are here. Okay, I'm gonna go ahead and answer the question and then I'm gonna shut her down. So here's the question. Okay, yes, because of some of the probabilities, yes, we already checked that. Oh, that's all it's going to ask. Okay, well, okay, this one don't ask a lot of questions. It just asked if it was the sum. Okay, so I did answer the question. All right, let me shut that down. I'm going to hit that and shut the recording down.